Welcome back to my channel. I'm Brian Kapke, and this is Master Databricks Step by Step, second edition. I'm redoing the series. It's been very popular. People like it, but it's fallen out of date from the original video. So I'm going to be going through each of the topics, adding some new ones with all the new features, and bringing the whole series up to date. And this is lesson 3, Understanding Clusters. So let's jump in. What are we going to talk about, Brian? We'll talk about what is a Databricks cluster, understanding cluster nodes. We'll walk through creating a Databricks, aka Spark cluster on Azure. And ultimately, it is really a Spark cluster, but Databricks adds its own secret sauce called the Databricks runtime. So that's the big difference between a Databricks cluster and a Spark cluster. We'll talk about considerations for when you create a cluster. And we'll also discover interview questions, because you know what? For some reason, this is a favorite hotspot for interviewers to ask you questions, and there are some really tricky spots in here. So I'll give you some answers that are good. Hopefully the interviewers will know that you're right. And then I'll wrap things up. So what is a Databricks cluster, Brian? I don't get it. It is really a Spark cluster, as I mentioned, with a Databricks runtime installed on the node. So the runtime is really sort of the overall execution engine and secret sauce in Databricks case. Now Databricks is a cloud-only environment, so it adds a lot of things, but a lot of what it's adding is performance improvements that really leverage a cloud environment like Azure. Now, a cluster is the compute that processes your code. What does that mean, Brian? I don't get it. Well, think about it. You want to run a program, right? But you need a computer to run a program. Your computer is called a compute. So when we talk about cluster, we're talking about a set of computers, one or more, that will be used to run your code. That's really what we're talking about. Clusters can use multiple machines and maximize parallel execution of code. That sounds kind of weird. What do you mean by all that? What I mean is the whole principle behind any of these scaled out environments like Spark is that they're going to break your job into many pieces and then run those pieces concurrently in parallel. Massive parallel execution. And by doing that, it can get the work done a lot faster and it can handle a lot larger data sets. This slide is meant to show you kind of an overall picture of what a Spark cluster looks like. And what you can see here is the services, Spark SQL, right? These are services that run the core engine, Spark core engine. You can see this light blue area here. The Spark core engine is the original pre 1.0 release of Spark, and it allowed you to do basic things, but then they added other services on top like Spark SQL. So you can use the structured query language we all know and love to be able to do things, and it's much more intuitive than what had been available previous to that. You also have MLlib, which allows you to do machine learning on the cluster. Those are built-in libraries and services on the cluster. Spark Streaming allows you to do streaming data sources, and GraphX is really a network kind of API, so you can think of like Facebook, where you have one person connected to another and another, and then it branches out, sort of like this sort of just like a branching type of view of things. On the left, you see the sort of sales brochure items. Spark supports batch processing, interactive SQL, real-time processing, machine learning, deep learning, graph processing, which is what this diagram is kind of all saying. So I just want you to have that in your mind. When you're doing, for instance, a SQL statement, it's kicking in the backend SQL service that supports that on the cluster. When you do something like data frames, let's say Python or R, it's using a lot of the same libraries, so it's not completely separate. So a Spark cluster supports Python, R, Scala, and Java. Now, if you know, Scala is actually sort of higher level language sitting on top of the JVM. So essentially it leverages Java under the covers, which is why Java is also supported. Now, you look at the bottom here, you see Yarn, Mesos, and the standalone scheduler. These are ways that the Spark cluster can be managed. It's called a resource manager. So Yarn stands for yet another resource negotiator. Mesos is another resource manager. And built into Spark, there's always been this standalone scheduler. But Databricks and Spark leverages Kubernetes. That's something that wasn't always true, but now the standard is that Azure Databricks will use Kubernetes across the board because it just is really an effective way to manage the cluster. So let's talk a little more about cluster nodes. It all starts with the driver. So picture a virtual machine, and you need to connect to that virtual machine. That driver, that first virtual machine, is your entry point. From that, you can submit statements and say, I want to query, I want to do SQL or whatever, and that will invoke these other machines called workers. Now, Spark clusters can have, and Databricks clusters for that matter, can have as many worker nodes as you would ever want. They will cost you money, but you can spin up as many as you want, and the driver is responsible for coordinating what you request, submitting it to the worker nodes. And there's other things going on behind the scenes to make it all work. The main thing is that in a large job with lots of workers, these will be running your tasks in parallel. It will basically break your really large request into chunks and then process those chunks in parallel. So you are here, you submit your request. Each node is a virtual machine, and that means it's going to cost some dollars. It's not free. Depending on the size of the machine you pick, which you can configure, it's going to cost you more or less. Also, depending on how long it needs to run to process your jobs. For each node, you need to figure out a few things. One, what Databricks runtime are you going to be using? How many core do you need? Those are basically how many CPU, and that's going to determine the level of parallelism, which is concurrency. If you have 4 core, you can run 4 tasks concurrently. If you have 8 core, you can run 8 tasks concurrently. How much memory do you want to be on this machine? Now you can create a driver node only cluster. In other words, you could just create this. Seems kind of weird though, because the whole idea of a cluster is to allow this scaling out. But there are times when, for instance, you're training, right? You're learning. You may have some small data sets, or in some cases, you may have, say, even something fairly large. We'll say like 20 gigs of data. Well, if you had a really large driver node, which could be configured, you could probably work on that without scaling out, which may be faster and may even be cheaper. So as I mentioned, the driver node is configured separately from the worker nodes. It can be set, we'll see, so that you just say make them all the same, or you can change the driver to be somewhat different. Maybe give it more memory so that you don't always have to use the workers. All worker nodes, though, must have the same configuration. And some configuration settings, in fact, most of the ones I can think of, actually apply to the entire cluster. For instance, if we enable Photon, that's not just for one worker node, that's going to be across the cluster. So let's create a cluster. I've logged into the Azure portal and I brought up my Databricks workspace, Databricks BPC. To launch it, all I need to do is go over here and say launch workspace. And then I can go wherever I want to do work. Now I've got a couple of dummy clusters here. Before I get too far in, I do want to point out something that I encountered as an issue. You may as well, if you've already been playing around with Databricks and you have, say, a workspace that's been around a while. This is something I did earlier. I created a cluster, but I did not have Unity Catalog enabled. When you don't have Unity Catalog enabled, you get this interesting thing down here. You'll see access modes that say legacy next to them, and that's kind of an indication that you won't be able to use Unity Catalog. And it's kind of a weird thing, but I found it was causing me a lot of issues, and I was very confused why I was seeing that. Once I enabled Unity Catalog, I didn't have this problem anymore. And I'll put a link in the description so that you can follow that to how to enable Unity Catalog, but it's very easy to do. So let's create a cluster now, brand new Databricks cluster. We're going to say create compute. Now again, on the left, this is our UI or navigation menu. You want to click on compute to create your compute. Now I will point out that if you're doing SQL warehouses, that actually is also a cluster, but it's designed just to support SQL workloads, not Python and things. So we're going to, and it's really not designed for ETL work. So we're going to focus on the ETL side of things. That's kind of my thing. So we're going to go here and say create compute, and we're going to name it test cluster. Now there's a few things I want to walk through here. First of all, since I am the subscription owner in this test case, I can do anything because I'm like God here, see? And that's what the policy unrestricted tells me. I'm unrestricted. I can do whatever I want. But I might have restrictions like only personal compute is something I can create, or power user, or shared. If I were in a real environment, I'd probably be limited to something like personal compute or maybe shared compute. So I'm going to leave unrestricted. That's okay. You can see here if I click on this, it tells me that I can have these machine learning libraries pre-installed on my cluster in case I want to do machine learning. So if I want that, I can just check off machine learning like that. I don't need it in this case. And then here, I pick my Databricks runtime. If I click this drop down, it's always going to pick some number, and we'll say LTS, which means long-term support next to it. And that's usually a good bet. I always go with the default because it seems to be picked to give you the least trouble in my view. But you can go with something more recent, especially if there's some feature that came out in 7.1 or even the beta that you want to use, and you can certainly do that. The reason they don't automatically, I think, set it to that is they're trying to make sure that all features work consistently. You don't run into kind of any glitches. And I have this option to pick Photon acceleration. So what is Photon, Brian? It sounds kind of Star Trek-y. Photon is a project within Spark. Now this is being done by Databricks, where they are rewriting the execution engine which was originally written in Scala and therefore uses the Java virtual machine, into a language which is C++ and C. By doing that, they're able to get rid of a lot of limitations. They were able to manage memory better and run things faster. So Photon runs a lot faster than the legacy Scala engine. Not everything has been migrated to Photon yet, but most of the big parts I think have been. So you can get massive performance improvements by using Photon. And generally I would say, unless there's a reason not to, I would say check it off. What about the node type? So we can pick any number of virtual machines. Now these are going to be virtual machines that are available in your cloud environment. So these are Azure virtual machines. We can pick whatever we want. They ain't free. Whatever I pick, though, I'm going to have to pay for. So if I go for this 192 gigabyte memory, 48 core machine, that's pretty hefty. But this gets into a question later. Here's the trick question. Somebody asks you in an interview, I have a petabyte or some amount of data. How many nodes will I need on my cluster to be able to support that work? Well, here's the deal. You might have nodes that are 192 gigabytes of memory and 48 core. Or you might have nodes that are only 16 gigabyte and 4 core. Obviously, I'm going to need a lot more of this smaller VM than I will of the larger ones. So the answer, and this gets even more extreme, you can see this one's 256 gigabyte. So the answer really is, it depends. Depends on really what you're actually querying also, but how big are the VMs you're using? What do you select? So there is no fixed answer for that. And if anybody says there is, I think they're hallucinating. You got to really look at what's going on here. And the other thing, as I mentioned, is you might have a petabyte of data, but if you think about it, you might be filtering out of a petabyte, we'll say 100 gig or something, or 10 gig. That's also going to affect it, because if you can efficiently filter out what you need, you may not need a huge cluster once you get that out. Or maybe you only need a few columns of a really large data set. So again, that can affect how much overhead and therefore how large a cluster you need. Now I said single node, but if I uncheck single node, I can set this to any number of nodes I want. So here I could say 2. Now I don't have much space on my quota. In other words, Microsoft's constrained me to not being able to create that much without me putting in a request to increase my quota, but I could do this, and then I can enable auto scaling. And what auto scaling does is it can automatically increase or decrease the number of nodes on the cluster from a minimum like 1 to a maximum like 8, depending on how much is being demanded of the cluster. In other words, it's kind of ratcheting how much it needs in terms of resources, and will only create another node if it needs it, which is nice because I'm only going to be paying at any given point in time for the nodes I actually need, and therefore the nodes that were actually created for my workload. So autoscale is a really important feature. If you're going to use a multi-node cluster, which is most likely in production definitely true, you're going to want to use autoscaling. The other thing that's really important, especially when we're developing, is using the termination feature here. So I can set this, it's 120 minutes, but I usually set it to say 25 or 30. And what that means is if this cluster is up and running and I walk away, I go have a cup of coffee, go chat on the phone, after 25 minutes, it will automatically terminate the cluster. And we don't pay for a cluster that's not running. I may have the definition of it still sitting in my list of available compute, but if it's not running, I ain't paying for it. And that's really important because the vast majority of your expense on Databricks is from the compute. Almost all of it, really. That's where the really heavy lifting is. So minimizing your compute is the key to saving money on Databricks. On the right here, you can see things like it shows you a summary of what you've got. Really important here also is you've got Unity Catalog, right? So Unity Catalog is available for this. Depending on what you create for a cluster, you may not have Unity Catalog available to you. So you always have to be very careful of that if you need Unity Catalog. Let's look at advanced performance. I had to kick this in. Spot workers. So spot workers are really great. It's a way of saving money when you create a cluster. What it does for a spot worker is it grabs a VM that's already sitting out in Azure and it just pulls it in, and it's a warm machine, so it spins up really quickly, but it still has to install the runtime and clean it up and get it ready to be deployed as a node, but it saves you a lot of money. Now the only catch is it may not always be able to get a spot worker available, in which case it will have to grab a non-spot worker and could cost you more. Generally, using spot workers, in my view, has always been only when you're doing development or it's not a critical workload, but it really depends on what your needs are. Now, driver type, you see up here, we've selected what our Databricks runtime and then our worker type is, but the driver can be different. Auto means it's going to basically create the same driver node as you have in your worker nodes, but I can go down here and say, you know what, I'm going to make a really heavy duty driver node. Why would I do that, Brian? That makes no sense. Well, I think I've already said this, but there are a lot of queries I do in which it's not really necessary to spin up multiple nodes. I might be able to create a really large driver node and then contain my query so that it just stays on the driver node without spinning up the other nodes. And if it's relatively small amounts of data, say it's 10 gig out of a really large data set, then I can get away without using more nodes, which can be a lot cheaper and probably save me money and time as well. It might be faster. It all depends on what you're trying to do. For really large workloads, that's not a good idea, but it could be something I selectively do. I've got a pretty good sized driver node that gives a lot more power, but it can also be used to kind of do analysis. There might be a reason why you want to have a more powerful driver node than your worker nodes. I can't picture many situations the opposite, but that's how I see it. Sometimes you may want something more powerful. You can create tags, and there's some automatic tags there. Let's look at advanced. One of the new things I saw, I came back after a while and came to the UI, and I saw this new thing with this access mode. And here you can set it auto. This is automatically configured to a standard and Unity catalog enabled cluster. But I can go to manual and then pick what I want. I can even go to creating some of these legacy modes, which are no longer really advisable. Go back to auto. I can set Spark configuration. I click Spark here and I can enter some Spark custom configuration settings here. I can set up environment variables here. I can control login by clicking on logging, and I can have volumes, preview, DBFS. So I can have logs written to the Databricks file system. I can query it through the notebooks, whatever. Here I can point to a script that I want to run when the cluster starts up. In the old days, this was typically used to install, maybe Python libraries or Scala libraries or something we wanted to have available on the cluster. But it could be used really to do anything you want to happen when the cluster starts up. All right, I'm not going to actually create it here. I'm going to say cancel, and instead I will start my demo cluster here. So I'll click this to start it and say confirm. All right, so we're in a notebook that I just started, and you can see here it's selecting data from a common data set already available through Databricks. What I'm going to do here, I need to change my cluster. Now notice here it automatically went to serverless, and I didn't have to, in this case, create the cluster. But instead I want to point to my other cluster, the one we just created. So I'm going to switch over, and then here I'm going to say shift enter to run that query, and you can see it gave the data back. I can change the cell and say I want Python, and I can say just print whatever I really want here, and it will run it, and it just shows it up here. So the main point here is that when you physically create your clusters not using serverless, as we did, we need to go over here and make sure we point to the cluster we want to use, and that's what's running. But by default, as we can see, it automatically went in and created a serverless cluster. Serverless means it's like you don't create it, you don't manage it. Databricks just creates it and uses it for you. In my experience, looking at the costs, serverless can actually cost you more money. It may save you more. So I would say, depending on what you're trying to do, be mindful of that. I personally still prefer, maybe I'm too old-fashioned, to create my own cluster, especially when I'm doing demonstrations and just demoing like this, where I can make it a single node, minimize the resources rather than just letting it create serverless, because you have a little less control, I think, with serverless. And I'll put a link into the description into the Microsoft resource calculator, which is when you're trying to figure out what something's going to cost in Azure, you can tell it what you're creating. I found in a recent project I did, I estimated using serverless and the cost went up a lot higher. So I'm not sure why that was, but it's something to be really aware of. And if you're going to use one or the other, just evaluate it and make sure it fits your needs. But in this case, I'm specifically pointing to my demo cluster here. And again, you go over here, you change it. It's going to ask you, do you want to switch? When you switch between nodes in a notebook, it's going to lose memory of what was there. It's going to kind of reset everything. So just be aware of that. I'm not going to do a lot of demoing here because the main point of this was just how to create a cluster. Again, going back to the compute. This is the cluster we created. We can see here the runtime, active memory available, how many core. And if we go over here, we can restart, clone, or delete the cluster, or we can create more clusters. So let's walk through creating a cluster again, the configuration options we have. First, we have the computer name at the top, the policy we talked about. Policy is going to be something you probably don't have control of in a real world scenario. More than likely, the admin will specify you can create only personal compute or shared compute. But if you are the owner and you have the abilities and the permissions, then you can get unrestricted and you can create whatever you like. We can see this machine learning thing if we want machine learning libraries to be installed, so we can do machine learning like using XBoost or something. We can check that off. Just make sure it's actually installing what you need, otherwise you're just adding overhead. We then set up our runtime. What runtime do we want? Do we want to check off photon acceleration? I can't think of many situations where you don't, but maybe you need Scala and you're running Scala code. Maybe it doesn't make sense. But in most cases, I think Photon is a good idea. What node type am I going to run? So that's the actual VM under the covers it's going to use and how much memory you can see here it's going to get. And in my case, I checked off single node because I'm cheap. I don't want to pay any more than I have to. And I'm only demoing, so I don't really need more. As I mentioned, you want to take advantage of this termination automatically because then you can set how many minutes before it will terminate a cluster. They set it to 2 hours, 120 minutes, which is a lot. So why not just set that down to something like 10 minutes if you plan to be there with it, or even 5 minutes. Really good idea though. I would highly recommend always setting an auto termination on a cluster because otherwise, unless there's some really good reason in production and you're running the cluster 24/7, you don't want to necessarily have to keep paying for that. That's going to drive your cost up. And if you're doing this for demonstration purposes, you could get a little sticker shock. You can see the driver node, single node are shared here. The part here I forgot to mention is 6.4 says LTS, that's long-term support. So you're generally going to try to stick to something that is what it recommends by default. Again, Photon gives you massive performance improvement. And on this slide, we can see the driver type. If we have multiple nodes, we can set the driver type different than the worker nodes. So here we can say same as worker, or we could set it to something very different. And I mentioned maybe you want to make the driver more powerful so you can do work without needing the other worker nodes. You can see enable auto scaling, and that's where we can say from 1 to 10 or 1 to 8 nodes. And Databricks will only add another node if it needs to based on the workload. Finally, you click on this to expand advanced options, and you can see what's the advanced options available. We can have storage credential pass through. This is generally a legacy feature. What it does is it says it passes your credentials through to Azure to see if you have authorization to query or do anything on the ADLS storage underneath the covers. Generally, you're going to want to use Unity Catalog to manage your access and not do this anymore, but it's still available. You have Spark configuration options you can control, logging, and init scripts here. So that's more features you have. So again, this allows you to set your Databricks login to be used for pass-through, and again, Spark, logging, and init scripts. Something I encountered, which you may not, is that I had not had Unity Catalog enabled on my Databricks workspaces because they had been around a while and I just never got around to enabling Unity Catalog. As a result, I was getting this annoying setting where it kept saying legacy single user standard. So this legacy single user standard was actually causing me trouble creating the cluster, but it's also something I don't really want to be doing. So let's talk about cluster interview questions. You're sitting here and this is kind of give you a reminder of a cluster. And the interview asks you, how many cluster nodes will you need to process X amount of data? Now, I already went over this, but I'm going to reiterate it just in case you weren't paying attention. It's going to depend on how many cores and how much amount of memory you have on the nodes you're allocating. That's available to you. And because this is such a wide, elastic kind of settings that you can configure, you really can't tell how much you're going to need. Not to mention the types of query you're running and how you're running them and how much data you're filtering. So that's really an insane question I want to say to ask. So the answer is it depends, and then you can go into those reasons why it depends. What programming language is the cluster execution written in? Do we remember this? Do we remember Photon? So originally the execution engine, everything in Spark was really written in Scala. Scala uses the Java virtual machine under the covers, so all of the nodes are running the JVM. Now the problem is this created memory issues, marshaling database, the JVM in and out, so it was constantly deserializing and serializing the data in and out, which is adding a lot of overhead. And there have been many libraries and things to simplify that, such as Arrow, but at the end of the day, the JVM was just putting a barrier on just how fast they could make Spark run. So the people at Databricks decided, let's rewrite the engine in C++ and I believe C to get this to run extremely fast and eliminate all of these barriers they've had, and it was very successful. Most of the execution engine on the nodes has been rewritten and uses Photon, but to my knowledge, not everything has yet. But probably it doesn't matter what isn't there anymore that's not converted, because the bottleneck type spaces most likely are. So here's a question that hasn't been, nobody asks anymore, but worth asking. Can I run unmodified, locally developed, in other words, wasn't designed for code on a cluster to run, Python or R data frame code on a cluster? And the answer is yes, you can, but if you try to run just say standard pandas code with the pandas library specified or R data frame code, it won't actually use the nodes. It will only run on the driver. And I saw people do this in the early days. They'd crash the cluster because they thought they could just take the code that they've been using on their own little machine, run it on Spark, and it would magically know how to scale out and run a petabyte of data using this code. It don't. However, there are a lot of things, especially with Python, to make it really easy to just to swap out the pandas library, switch it over, and then you can get the code to run fine, and it will be cluster aware and cluster enabled. And finally, something that comes up with clusters a lot is performance tuning. A lot of people, especially in interviews, are likely to ask you questions around, if you got slow performance, what are you going to do? How do you make performance do better? Yada, yada, yada. What I've been watching over the few years now, since Databricks came out, is a constant improvement in the automatic performance tuning within the Databricks clusters. What this means is with all these features like, say, Photon, with all kinds of cluster features and runtimes and all the different things they're doing, there's less and less need for you as a developer to stop mucking in with special configuration settings on the cluster or modifying all your code to do this or do that, or trying to force it to partition a certain way or bin data a certain way. And there's lots of techniques out there. I think the need to do that is less and less. There's even something will automatically tune your code in the engine. So it's really becoming less and less necessary to do that. In an interview, unless you're an expert on this stuff, I would focus on those things and say I would first try to use the inherent features of Databricks to optimize performance before I would start trying to force Databricks to work a different way and force the cluster to do things, because you may muck things up and maybe you got good performance now, but if they change the way Databricks works, it may actually not work so good in the future. Again, there's a link here and I'll put it in the description. But the other thing I want to mention is choosing the right cluster, getting that sizing correct, I think is going to be a really important feature. And not just the size, but the type of cluster you need depending on the type of workload you're running. Like, are you doing a job, or are you doing something that's interactive querying? On and on. Those things will make a big difference in your performance as well. So we talked about what is a Databricks cluster, and we learned that a Databricks cluster is just a Spark cluster that's using the Databricks runtime on the cloud. Databricks is a cloud-only service. We talked about cluster nodes, and we learned that we have a driver node, which is your entry point. It's where you submit all of your queries and things, and sometimes you can run with only the driver node itself, but usually if you're going to take advantage of the big data power, you're going to have worker nodes also. And the driver node will take your queries, and when it needs those worker nodes, it will automatically, through the engine, partition up your data and run your queries in parallel. We walked through creating a Databricks, aka Spark cluster on Azure, and we did a little demo of using it. And I talked about cluster considerations. These are all settings and things you can do to make the cluster what you need. Also went through some trick questions, things that they ask in interviews. Clusters are actually becoming really important and more complex all the time in Databricks. So 6 years ago, there weren't a lot of options on clusters. You had a few settings and that was it. Now there's a lot of features. Do I use spot instances? Maybe serverless. How do I want to set up? What kind of machines do I want? VM? Do I want machine learning optimized VMs and CPUs under the covers? There's all kinds of things here, and all of these will affect your performance. And that's it for this time. So I want to thank you. Please like, share, subscribe. Until next time, I'm pulling for you. Thank you.